Hello friends, I am Anuj Paul and welcome to my channel GyanWithAnuj. I have started this series Demystifying AI ML to explain AI ML technologies in a simplified way so that beginners can relate to it. In this video, I will talk about what are the steps of an ML project, or in other words, how an ML project is executed. Now, before I started learning this domain, I had many questions. Do we write complex algorithms in every project? What exactly is an ML model? What is training of ML model? What is test? How do we test it? Let's see if we can answer some of these questions in this video. Now, a disclaimer to start with, this video we will exclude deep learning, LLM and Gen AI. At a high level, the ML project can be broken down into these main stages. Number one is defining the ML problem or converting a business problem into an ML problem. Number two, collect the data and prepare it using data analysis so that you can use it to train the model. Third step is to select the model and train it. Next would be testing the model, and lastly you deploy it to production working on real traffic or live traffic. So let's look at them one by one in detail. The first step is to convert the business problem into a ML problem. Now, what it really means is that we define a very specific goal for our ML model to predict, which is related to the business outcome we want. For example, if you want to build an ML model that can catch credit card frauds, now the business problem is to identify fraudulent transactions. But if you have to define a very precise goal for the ML model, you can say predict if the transaction is done by the cardholder. So ML model is going to look at the data and predict if the transaction is really done by the cardholder, right? That would tell us if it's a fraudulent or a non-fraudulent transaction. Once the ML problem is defined, the next step is to collect data that will be used to train the model. Now, data can be collected from various raw sources. So it's important to ensure that the quality of the data is good, because that directly impacts the prediction that the model is able to do. Now, this is achieved through a process called exploratory data analysis, or EDA, right, where we look at various characteristics of the data set and identify the set of attributes or features. Now, this is a term that you must have heard if you have read anything about machine learning or data science. So the data set have typically attributes, and those attributes are called features. So this analysis is done to identify which features should be kept and which features need to be dropped, so that we can improve the quality of the data. Now, for example, we will analyze the attribute and we'll look at if there are a lot of missing data in that attribute, right? Or if the data in the attribute is pretty skewed, right, and it may negatively impact the output, or the correlation of these features to the eventual output. If the correlation is not good, then also we might want to remove some of those attributes. And sometimes we fix, for example, if there is missing data and if we feel that no, that attribute is important and that missing data can be replaced through some constant or let's say mean of or average of the other values in that attribute, so we can do that, right? So that's what this whole step is about, to analyze the data, look at a lot of characteristics, and typically these are we do using statistical metrics, right? And then we finalize which attributes to keep. So we call it feature selection, right? We select the features that you will use to train the data. Now, do we do all of this manually? No, we don't need to do this manually. There are Python libraries that allow you to look at various as I said, statistical metrics or characteristics of the data. For example, you can identify unique counts in a attribute. You can identify what is the cardinality, or how skewed is the data, right, and so on. Or you can plot. Those libraries allow you to plot. You can do a scatter plot and see the correlations, right? So that's how you do this step, and you analyze and you finalize the features that you want to keep. I'll do a separate video on EDA and feature selection, and obviously we'll try to get more deep into the whole step and the tools that are available to do that. And once we prepare the data, next step obviously is to now use this data to train the model. But before we train the model, we have to do another step where we have to split this data to keep a percentage of this data for testing the model once we trained it, right? Now, this is important because how will we know if our training is good, right? If the model is well trained, when do we need to stop? When we say training is complete. So, we need to test the model, right, once it is trained. So, what we typically is done is the original data set is then split kind of randomly, right, and in a 85 to 15% ratio. So, 85% will use for training and 15% will for test, and these are typical ratios. So, now again we do not do it manually. There are Python libraries that has this feature that will automatically split the testing and the training data. Now, training and testing data will have exact same features which we have selected in the previous step, right? Only thing is the amount of or the volume of data would be lesser in testing, as I said, around 15%, and training would have 85%. So, now that we have kept aside the testing data, we have the exact data set that we want the model to be trained on. So, next step is obviously training the model. But what it really means to train the model, right? Now, ML model is nothing but a program that executes a statistical algorithm that we will select, and it will take the input data features that we will provide, and it will try to predict an output. Now, the algorithm that we will select is based on the type of problem we want to solve. If it is a classification problem, we will select a corresponding algorithm. If it is a numerical prediction we want to do, we will select a corresponding algorithm. Now, once we select an algorithm, right, and we pass the input data set that we have created, right, to it, what the model does is it is trying to create a mathematical function of all the features in that data set and add parameters to that function, so that it can predict the output. Now, these parameters are completely controlled or set by the algorithm itself as it continues to identify the patterns in the data, right. So, that is primarily what training is in a very simple way, right, and the objective of the training, right, is to calibrate those parameters so that our prediction is at a certain accuracy or whatever the success criteria we have set for our prediction, right. If we say that our prediction should be 80% accurate, right, then the objective of this whole training exercise is to calibrate those parameters and optimize that final function involving those features to arrive at an accuracy of 80% for the prediction that the model would do. So, training and testing, these are two steps that can happen in recursion, because once you test, then you only will be able to match the prediction output with what we desire. As I said before, both have exact same set of features or attributes. The training objective, as I said, is to calibrate the parameters, right, which optimizes the function. Testing doesn't change those calibration. Testing is just using the function that is arrived at during the training to predict, and then match the prediction the actual data, right, to see how accurate the prediction is. That is how the training and testing happens, and once we reach those success criteria, the model is ready to be deployed to production. As I said, model is eventually just it's a program, right. So, it gets deployed to production, which typically means that now it will get the input as a feed. Now, that feed could be a live feed if you are solving a problem where you need model to predict on a real lifetime traffic, or it could be feed that is giving data in batches, right. If it is a background process where we are doing some background processing and some predictions or recommendation if you are trying to come up with, right. So, that depends, but eventually the deployment is nothing but it is taking input right from the actual production data and then it predicts the desired output, whether it's a classification, whether it's a numerical prediction, whether it's a true false kind of a prediction. Now that prediction obviously can be fed to again different systems depending on what's the business use case, right? If it's a weather prediction, it might show up on a weather website, right? If it's a typical true false kind of a scenario, then that can further trigger a rule or a business logic in any program. So the output can be fed to any program or for a customer facing use case, or it can be for a backend processing. So that's what typically happens, in a very simple, at a very high level, how an ML project is executed. Hope this video helped you understand what it takes to do an ML project end to end, right? And I'll keep sharing more such information on AI ML technologies as I keep learning, and I'll keep sharing my learnings, and keep watching the series, and do subscribe if you find this useful. Bye. Have a great day.